Hi, welcome to my channel pibyme Maths. This is by WST01. Here we are solving January 2024 Statistics 1 paper. In the previous video, we covered question number 1 to 3. Let's look at question number 4. A French test and a Spanish test were sat by 11 students. The table below shows their marks. So there are 11 entries here. Okay, there are 11 entries. Okay, French mark and Spanish mark. French is taken as F, Spanish is S. Okay. Now, Greg says that if these points were plotted on a scatter diagram, then the point 30, 90 would be an outlier because 90 is an outlier for Spanish mark. He claims that this is an outlier, 30, 90. So an outlier is defined as a value that is either greater than this or smaller than this. Show that 90 is an outlier for the Spanish mark. So I'm going to take the Spanish mark alone here. Now we are going to find Q3 upper quartile and Q1 a lower quartile for the Spanish mark. But before finding the lower quartile, upper quartile, you need to write the values in ascending order first. But if you look at the values are all in ascending order. Only 90 is here. You need to put it here. Now the values are in ascending order. So there are 11 entries. So to find Q1, you divide 11 by 4. To find Q3, you times it by 3/4 because that's a 75th percentile. So let's calculate these values first. 11 over 4 is 2.75. And then times 3 is 8.25. So if you get a decimal number, you take the next entry, third entry and ninth entry. So third entry, 1, 2, third entry is Q1. Q1 is 28. And then 4, 5, 6, 7, 8, ninth entry is Q3. And then you find IQR, interquartile range, is Q3 minus Q1, which is 20. So we got all these values now. Now we need to calculate this and this. So if you put Q3 plus 1.5 times Q3 minus Q1, that's interquartile range. 1.5 times 20 is 30. Q3 is 48, so you get 78. And then Q1 is 28 minus 1.5 times 20. 28 minus 30 is negative 2. So this is the range minus 2 to 78. Range in the sense like if a value lies outside this range, smaller than minus 2 or bigger than 78, it's an outlier. So they are talking about 90, so you need to write 90 is bigger than 78, therefore 90 is an outlier. That's how you write the conclusion. Part B now. Ignoring the point 30, 90 because it's an outlier, Greg calculated the following summary statistics. Use these summary statistics to find the equation of the least square regression line of S on F for the remaining 10 students because we remove one entry already. So now the N is 10. They want you to find the equation in this form. So to find the equation, first you need to find B. The formula given in the data booklet is SXY divided by SXX. Sometimes you will be confused what is X, what is F, what is Y. So compare this equation, Y is equal to A plus BX with this. So X is F, Y is S. So it's going to be FS over FF. So take these values and sub in here. You will get 1735.6 divided by 1667.6. That's going to be the value of B. 1735.6 over 1667.6. 1.0407, etc., etc. If you round it to 3 significant figure, you get this value. And then to find A, the usual formula is Y bar minus BX bar. In this case, it's S bar minus BF bar. S bar is sigma S over N, 382 over 10, minus the value of B. Don't use the rounded value, use the actual value, times F bar, sigma F over 10. You get this value. Let's calculate this. 382 over 10, which is 38.2, minus I'm gonna use the answer, that B is the previous answer, times 422 over 10. So we got minus 5.720 ... So you can finally write the equation. Therefore, Y is equal to, Y is as A is this value when you round it to 3 significant figure, this, plus B, X is F. In this case, it's a 3-mark question. Part C. Give an interpretation of the gradient of the regression line. The regression line is S is equal to minus 5.72 plus 1.04 F. Okay? When F is 0, S is minus 5.72, right? When you increase F by 1, the S value from this, it increases by 1.04 times 1, right? So when you increase F by 1, S increases by 1.04. You need to change it to a sentence related to the context given. F is the mark in the French test. S is the marks obtained by the students in the Spanish test. So for every extra mark gained in French test, the student's Spanish mark will go up by 1.04. That's how you need to write it. You don't write this sentence. This is just for your reference. You need to write related to the context given. Part D now. 2 further students sat at the French test but missed the Spanish test. Use the equation in part B. The equation in part B is S is equal to minus 5.72 plus 1.04 F. Use this to find the Spanish mark for the student who scored 55 in French test. So replace F by 55. So S is going to be minus 5.72 plus 1.04 times 55. You will get the score. And 18 in French test for double I. F is 18. So S is going to be minus 5.72 plus 1.04 times 18. Let's calculate these two values. Minus 5.72 plus 1.04 times 55. 51.48. Leave it as it is, do not round it. And then 18, you get 13. That's the answer. Now part D, state giving reason which of the two estimates found in part D would be the more reliable estimate. Okay, here we got two answers, right? When we subbed in F is equal to 55, we got S is equal to 51.48. When we subbed in F is equal to 18, the S is equal to 30. Okay, so the value we subbed in, right? We need to check these values comes from the data within the range. If it's within the range, it's interpolation or it's extrapolation. So let's look at the French data here. French score, French test marks. The least mark is 24. The highest mark is 68. We subbed in 55 and 18. So the question says, State giving a reason which of the two estimates found in part D would be the more reliable estimate. So the range from the table is 24 to 68. That's the range of the values of F, 24 to 68. Apparently this value lies in the range, not this, right? So you need to write 55 lies within the range. So it's interpolation, and therefore it's more reliable. It's more reliable. 18 lies outside the range. So it's extrapolation. And the model may not be reliable. The value we calculated in part D, you need to write the value we calculated in part B may not be reliable. That's how you write the answer. Let's look at question number 5. The distance an athlete can throw a discus is normally distributed with mean 40, standard deviation 4. So I'm going to write it as x follows normal distribution of 40, sigma square. Using standardization, show that the probability that this athlete throws the discus less than 38, P of x is less than 38.8. We need to prove that the probability is this. So let's standardize this using the formula x minus mu over sigma. So Z is x minus mu is 40, this is sigma over sigma. So we'll get P of Z is less than 38 minus 8, 38.8 minus 40 divided by 4. You get minus 0.3. So finding the value of the left hand side of a negative number is same as finding the value of 1 minus the left hand side of positive value. So let's take the table value for 0.3. For 0.3, the table value is 6179. 0.6179, 1 minus, so it's going to be 0.3821. That's what they want us to prove. Easy 2-mark question. Let's move on to part B now. An athlete enters a discus competition. To qualify for the final, they have 3 attempts to throw the discus a distance of more than 38.8. Okay, they have 3 attempts. Once they qualify, they do not use any of their remaining attempts. That means they have 3 attempts. In the first attempt itself, if you can throw more than this meter, they don't need to use second and third. Let's say in the first one they failed, they can use a second attempt, and if they throw more than 38.8 here, they don't use a third one. If they fail here also, they need to use the third one. Okay, so they have 3 attempts. Given that they qualified for the final and the throws are independent, find the probability that this athlete qualifies for the final on the second throw, which is with the distance of more than 44. Okay, this is basically a binomial distribution and the normal distribution combined actually. So to qualify, they have to throw more than 38.8 meter, right? And we just calculated less than this value. So more than is 1 minus of this value, which is 6179. 0.6179. So they have 3 throws, and to qualify they need to throw, out of 3 they need to throw the discus more than 38.8 at least once, right? So the probability of success is 0.6179. It's binomial distribution. I'm going to define another variable, binomial distribution of 3, 0.6179. And they have to throw this distance at least once. So greater than or equal to 1, which is y is less than 1, which is 1 minus p of y is equal to 0. In binomial distribution, remember this formula, p of x is equal to x. The formula is ncx p to the power x q to the power n minus x. You will learn this binomial distribution in detail in statistics 2. But in S1, they always ask this type of question together with normal distribution. So how to recognize this question? Whenever they say like 1 out of 3 or 2 out of 3 or 2 out of 5, that's binomial distribution. In this case, this is not mentioned, but you need to understand, to qualify they need to throw this distance at least once out of 3 attempts. So it's binomial distribution. So 1 minus nc0, n is there are 3 attempts, 3c0, p to the power 0, q to the power, this q is basically 1 minus p. So 1 minus p is 0.3821 to the power 3. You just need to calculate it. So 0.3821 to the power 3, and then subtract the value from 1. We'll get 0.9442 etc. I'm gonna store this value as a, put a little reference here. Okay, we calculated this actually. This is the probability for the person to be qualified for the final. Okay. Now what does exactly the question B says? Given that they qualified for the final. So whenever they say given that a condition, that's conditional probability. So the person has qualified for the final. Find the probability that this athlete qualified for the final on the second row with more than 44. X is greater than 44 on second row. They want you to calculate this probability. Okay. So remember we have stored this value as A. Now what is the formula for conditional probability? P of A given B is P of A intersection P of B divided by P of B, right? What would be the intersection of these two? Just think about it. He has 3 throws actually. He can throw more than 38.8 here, and these 2 is not gonna use. So he's qualified for the final. Or first one he failed, second one he got success, third one he's not using it. Or first 2 he failed, third one he got success. Anyway, he'll be qualified. There are 3 cases. So in all 3 cases he'll be qualified for the final. So which one is intersecting with the second success? Second success is this, but instead of throwing more than 38, just more than 38.8, he is throwing 44. Okay. So in the first one he failed. That means he throwed only less than 38.8, right? So the probability for that particular less than 38.8 is what we calculated here. 0.3821. 0.3821 times. In the second one he got success, he throwed more than 44, which we yet to calculate, divided by probability for him to be qualified, which is what we calculated as y is greater than or equal to 1, right? We stored it as this value 0.9442 etc. We need to calculate this actually. To calculate this, first we need to find P of x is greater than 44. P of x is greater than 44 is, use the standardization, z is greater than 44 minus mu over sigma. So when you calculate this, 44 minus 40 is 4 over 4. P of z is greater than 1, which is same as 1 minus P of z is less than 1. Z is less than 1 is here, 8413. So you will get 1 minus 0.8413 is 0.1587. So the probability here is on top 3821 times 0.1587 over this. We need to calculate this now. So 0.3821 times 0.1587 divided by this value. I have stored the value as A. So the answer is 0.06422, etc., etc. If you want, you can round it to 3 significant figures, 642. That's all. It's a 5-mark question. Question number 6 now. The events A and B satisfy this. Show that they want us to frame this equation. Okay. Let's start with the conditional probability. The formula for conditional probability B given A is P of B intersection A over P of A, right? And then use the probability addition formula. B intersection A is same as A intersection B. So if you use the probability addition formula, it can be written as P of A plus P of B minus P of A union B divided by P of A is equal to P of B given A. Now just sub in all the known quantities. P of B given A is 0.3. So we'll get 0.3 is equal to P of A plus P of B minus A union B divided by P of A. Okay. Bring the x here. 0.3x is equal to x plus y minus 0.65. Okay, first simplify this. I'm going to put this here and the number here. So 1 minus 0.3 will get 0.7x plus y is equal to 0.6y. We need 20y instead of y. So we're going to multiply the whole equation by 20 and you get the answer already. 14x plus 20y is 13. That's all. Easy 3-mark question. Let's look at part B. The events B and C are mutually exclusive. If B and C are mutually exclusive, B intersection C is 0. And then B union C is given, P of C is given. Find the second equation in X and Y. Okay. Use the angle addition formula here. You can write B union C as P of B plus P of C minus P of B intersection C. Or since they are mutually exclusive, this will be 0. You don't even need to write it. Is equal to 0.85. Use P of C. This P of B is given as Y here. So y plus half x plus y is this. Multiply through it by 2. First of all, 2y plus half x plus 2y is 0.85. Multiply through it by 2, you will get x plus 4y is equal to 0.85 times 2. That's 1.7. That's take it as equation number 2. Then solve equation 1 and 2 now. This is equation 1. 14x plus 20y is equal to 13. And then I'm going to multiply the second equation by 5. Second equation by 5. So 5x plus 20y is equal to 7 5s are 3, 8.5. And I'm going to subtract them. So we'll get 9x is equal to 13 minus 8.5, which is 9 over 2. X is going to be 1 over 2 or 0.5. Sub in x here. From the second equation, 0.5 plus 4y is 1.7. 4y is 1.2. Y is 0.3. Always use your calculator to verify the answer. Go to equation number 1. 1, 4, 1.7. And the second equation is 14, 20, 13. Okay, 0.5 and 0.3. That's the correct answer. Let's move on to the last part. It's a 2-mark question. Determine whether or not A and B are statistically independent. If they are independent, P of A union B P of A intersection B should be equal to P of A times P of B. That's what we are going to calculate. So P of A intersection B is equal to, let's calculate P of A intersection B. Is it given here somewhere? No. We need to calculate using probability addition formula. It's P of A plus P of B minus P of A union B. P of A is X, P of B is Y, P of A union B is given here, 0.65. So you will get 0.15. Now find the right hand side, A times B. 0.5 times 0.3. 15, 0.15. So here you don't write this first, here you write, therefore P of A intersection B is equal to P of A times P of B. Therefore A and B are statistically independent. You can just write independent events. That's all. Easy 2-mark question.